Hey, geometry, let's check out proof number 1 together. We'll just give you some quick videos to help you figure this out. All right, use the diagram and the given information to complete the proof. I know that the measure of angle 1 is equal to the measure of angle 3, and I'm trying to prove that the measure of, or that angle AEC, this big guy here, is congruent to DEB. All right. So what I'm looking for is, and I want to think about, and I want you to get in the habit of thinking about a plan first. So before I write up on my statements and justifications, let's go ahead and talk about what are we planning to do. If I know that the measures of these two angles are the same, what do I know about the measure of angle 2? I know that the measure of angle 2 is going to be equal to itself, which means that I'm going to be able to use the segment or the angle addition postulate and add it to 1 and 3. If I know that 1 and 3 are equal, and I know that 2 is equal to itself, then guess what I can do? I can add them together, and then I can recognize that those two things have the same measure. All right. So let's go ahead and talk about what we have as a given statement. I know that we are given the measure of angle 1 is equal to the measure of angle 3. And how do I know that? It was given to me as information. All right. So now what I know is the segment addition postulate is going to allow me to add angle 2 to get my larger angles. So if I know that the measure of angle 1 plus the measure of angle 2 is going to be equal to the measure of angle AEC. And how do I know that? The segment addition postulate. That says I can take two angles and add their measures together. And guess what? I'm going to do my second angle at the same time. I'm going to say the measure of angle 3 plus the measure of angle 2 is going to be equal to my second angle, DEB. The measure of angle DEB. And both of those together are in my second statement with the segment addition postulate. Okay. So now I want you to think about what my next statement says. I'm going to go ahead and I'm going to say that the measure of angle 3 plus the measure of angle 2 is equal to the measure of angle AEC. I want you to think about that for a minute because you're probably like, wait, what? Where did she get that? And how does she know that that's what works? If 1 is equal to 3, I can go ahead and substitute this measure of angle 1 and the measure of angle 3 in for each other. So I chose to put 3 into 1. So this measure of angle 3 substituted in for that measure of angle 1. So I'm going to go ahead and call that my substitution property of equality. All right, so now I have some interesting conversations. What do I have? I have these two are equal to each other, and I have these two. So now I can think about how it is that I want to do it, and you have a choice whether or not you're going to substitute this in for here, and that to me actually makes the most sense. So for number 4, I'm going to go ahead and because measure of angle 3 plus measure of angle 2 is equal to this, and the measure of angle 3 plus measure of angle is equal to this, I'm going to go ahead and make a statement about these two. I'm going to say the measure of angle DEB is equal to the measure of angle AEC, and I can again use my substitution property of equality. Somebody might say that's also transitive property of equality. I'll buy that. And I'm so close. I'm almost finished, but I'm not quite there yet because that is not what I was asked to prove. So my proof is actually going to say that angle DEB is congruent to angle AEC. And of course, you know this is my definition of congruent angles. We can just say congruence if you want to. And then if you want to be super duper picky, you can go one step further and say angle AEC is congruent to angle DEB. So now I exactly match what I was asked to prove. And the reason why I can flip them around is the symmetric property of congruence. All right, that's proof 1.